I remember one day going to my partner and saying, "Hey, there's this thing called MLX. It's open source. We will not make money from it, but I want to try. Like I really want to try." She looked at me and said, "Okay, if you're going to do this MLX thing, you have to be the best of the best." And I looked at her like, there are people that are building this. How do you want me to be the best? So it's a lot of pressure. And I said, okay, I will take that challenge on. I really want to do this MLX thing. I made my first PR.
All right, everyone, welcome to another episode of the TWIML AI podcast. I am your host, Sam Charrington. Today, I'm joined by Prince Canuma. Prince is an open source developer focused on optimizing AI inference on Apple Silicon devices through projects like MLX-Audio, MLX-VLM, and MLX-Embeddings. Before we get going, be sure to take a moment to hit that subscribe button wherever you're listening to today's show. Prince, welcome to the podcast.
Thank you for having me. This is so surreal. I went from from being a spectator of this fantastic podcast, especially back in the day with MLOps, and coming today to talk about what I am excited and working on currently, which is surreal as well.
Yeah, I am really looking forward to digging into our conversation. I consider myself a beneficiary of your work, bringing lots of interesting models to Apple Silicon devices, one of which is sitting on my desk here. And, I'm really curious about like how you got into it and, how you approach it, where you see things going. How did you begin working on Apple Silicon?
So I'm originally a machine learning research engineer. So I've been working on optimizing ML inference as well as training pipelines. So you can think about the models that are state of the art in open source. I contributed to some of them as well from RC and helped many companies establish their MLOps pipeline for training and inference. So I've always been focused on optimization and making sure that we can get the most out of the hardware that we have as well as software. Contributed a lot to projects like PyTorch Lightning and many others in the space. Um, I got started with MLX 2023, end of 2023. So I just left Neptune and I was just experimenting with different things. I tried some projects and then I saw MLX for the first time. At the time, I had like a MacBook M1 Air. I only got it because I wanted the lightest laptop and the most uh, durable laptop, and like that was a gamble. Apple's first silicon version on the Mac, and I was like, okay, let me try it out. We already use iPhones every day. Let me see how this goes. So I bought it, and I was just trying it out. I install MLX. I try inference the first time. It was pretty slow. And
It was
it was
very slow.
it was really slow. So I looked at it. I said, okay, I will not judge it from day one. I think the promise is here. We can quantize models locally pretty fast. And when I saw how fast the quantization process was, that's where it hinted me that this will get better. And I started investigating more. I got to know the people behind it. So Anwi and the MLX team. Angelos is one of the other people that I know. So I reached out and I started looking what they're doing. Their GitHub was super active. And I remember one day going to my partner and saying, "Hey, there's this thing called MLX. It's open source. We will not make money from it, but I want to try. Like I really want to try." She looked at me and said, "Okay, if you're going to do this MLX thing, you have to be the best of the best." And I looked at her like, there are people that are building this. How do you want me to be the best? But that's kind of the standard I set always, and my dad has set for me as well. So we were never allowed to have second place. Like in my family, that's like not a reality. You're either the best or not, and that's why he gave me the name Prince, and my sister's name is Queen. It's like it's
Oh,
a
wow.
lot of pressure. Yeah. So it's a lot of pressure. And I said, okay, I will take that challenge on. I really want to do this MLX thing. I made my first PR. This was porting Hugging Face Star Coder 2 to MLX. I said, okay, I'm going to do it during the weekend. I get to the weekend, there was already a PR. But when I looked at the PR, I saw that there were a lot of things missing. I said, okay, let me try and do this. So I make a parallel PR. My PR gets working, but the person that sent the original PR was already almost finished, but was just missing one tiny part. So they looked at my PR, said, okay, we're gonna close this PR, but we're gonna take the thing that works and put it in another PR. Okay. And we will add you as a contributor. I said, great. So that was the first contribution to MLX. And after that, I just got addicted. I said, okay, MLX has the promise of local inference that PyTorch and TensorFlow and many others tried in the past, but didn't really succeed. It's the fastest way. Of course, there is Llama CPP, and Llama CPP is great as well. But when I looked at MLX, I said, okay, this is optimizing only for Apple Silicon. So there is untapped potential that we'll be able to reach compared to a more general approach. And we have the people that are designing the chips helping us do this. So I said, okay, what's missing in MLX right now? First, it was the models. We just didn't have enough models. Second, we didn't have enough operations, so enough modules to be able to build new models. I set out the mission to establish the developer tooling as well as port as many models as possible. So I ended up porting 1,000 models last year to MLX. These are mostly quantizations. If you count just models, it's around 20 to 30 individual model, but quantized in different versions or sizes of the model are more than 1,000. So I started contributing. It was week over week, day over day, and as the more I did, the faster I got. So it got to a point where any new model released on the internet, it would only take me like 30 minutes to port it to MLX. So people started getting this idea that I am some kind of a superhero because I would be on Twitter just waiting for a model to drop, and then the moment that model drops, I would port it as fast as possible. And and then there was this situation in particular in the beginning that made me even more committed to MLX, which was there was a model, I think from Cohere, that was like 100 billion parameters, and I only had the MacBook M1 with 16 gigabytes of memory. It's impossible to run that model there. Like there is no way you would be able to run it at a sufficient speed.
This
So I
was,
was
I'm trying to remember the name of that model.
Command R,
Uh,
I think.
the Command R.
Command
Okay, I was thinking of an earlier one. Command R. Okay,
Probably is an earlier one. I don't know if it's exactly that because they released so many now. But what was one of the early Cohere models, 100 billion, and I said, okay, this is not fun. Most models are small, but this is too much. So I literally coded that model blind. So I just coded the model and I asked Anhui, one of the creators of MLX, to run it on his MacBook Ultra, Mac Studio Ultra, and he would give me feedback whether the code ran or not. So that was a very interesting experience. So I was just totally blind. I had no idea whether it would run or not. He just ran it. It was like, oh, it's working or it's not working. And based on whatever error he sent me, I would pretty much change my code and send a new commit. And around that time, I started thinking, okay, if I really want to take this seriously, I need a more powerful machine. At the time, I was working with a fund they fund pretty much exceptional individuals to run projects. I was funded to create a series of models, open language models, including data. So I created the Misuse. It's a 2 billion parameter model that punches way above its weight, or at the time it did. And I just was working on that whilst doing MLX. So I used pretty much e enough of like 6 months rent, of the year, and I put that on the MacBook that I have right now, which is an M3 Max. And then the
I thought you were
community.
gonna say studio.
No, a studio is coming. Actually, I just ordered it last month, so the studio is coming. Um, So I ordered the M3 Max. The community was outraged. How come Prince does not have like a big machine? I was doing this really out of love, and when I really care about something, I go all in. I don't know how to go halfway. People said, "Okay, Apple should give you something." I said, "No, I'm not really doing it because I want something from them." And we ended up talking, and I was like, "Oh, this is not really something that we can do." And I said, "Of course, don't worry about it. I do this out of love and I will find a way to make it work." So I gambled on 6 months rent on the M3 Max, and it panned out. So I did some of my best work in the past year because of that. I managed to build MLX Vision language models, which is basically running all of the best open source vision language models on your Mac, as well as on your iPhone now with the Swift implementation. And I also happen to create MLX-Embeddings as well as audio thanks to a much bigger and more powerful machine. Um,
Let's take a step back, and I'm trying to remind myself of that early history. Like, I also had an M1 MacBook Pro, and I remember kind of as you described, like in the early days, like it was clear it was an amazing machine, just, relative to the Intel Max in terms of like the everyday user experience. Like it was, snappier, like you had a lot less of this whole spinning beach ball thing that we used to remember from the Intel days. Uh, but for running ML models and local inference, like for a long time, if I'm remembering correctly, there really wasn't anything there. And then like we had Llama CPP, and that became kind of like a general framework in a sense that I remember like when Whisper came out, like we were waiting anxiously for, the Whisper CPP version. And I've not talked to Georgie. Do you know Georgie who does those models?
I know him. I don't know if he knows me, but I
Okay.
follow him. I follow him, and I interact sometimes. But
Well, same here.
yeah,
So, he like, is one of the first folks, at least that I know of, that was like trying to bring these models to Mac. And I guess where I'm asking for you to chime in is like, my memory is that it was after that that MLX came out. Like MLX didn't come out with the M1 devices. There was a bit of a lag, and Llama CPP was first. But then it was like, this is the thing, and oh my God, it's fast. Like, am I remembering that history right?
no, you're remembering it correctly. So I think, if I'm not mistaken, Llama CPP came early with the first open source large language models. So you could run, I think, Mistral, the early Mistral models, and so on, and even Llama. I think the name Llama CPP also comes from the Llama series of models. MLX only came out, if memory doesn't escape me, end of 2023. So around December 2023, that's when it was originally released. The first M1, I remember getting my M1 in 2020, which was around the time it was released. So around 3 years lag between MLX and the first series of Macs with Apple Silicon. So yes,
MLX an official Apple product?
well, there are questions about that. They did get the recognition this year with WWDC, so it was in the forefront of WWDC. But before that, it wasn't really a lot of indication, but it is a official Apple product because there is an actual Apple team of employees working on this. How
Is it like on like an Apple GitHub account, or is it a separate GitHub?
Yes, so they have a GitHub that is, I think, ML Explores, and that is a repo that belongs to Apple. If you look at any MLX code, MLX-LM in particular, you'll see at the top Apple copyright.
Okay.
So as far as I know, it is. How center of their strategy it is, I don't know, but I think it should be.
Do you have a sense for whether MLX is used in Apple products? Or is it, an external library, but like they're writing directly to lower level hardware or doing something different when they're, building out their apps?
As far as I know, at the moment, it's not being used in any official product. They're using mostly Core ML and Swift, and also they have their own package, the Foundry, I think, a Foundry something that was released recently. So those are the main products that are being used to run their AI strategy. MLX, I'm not sure, but I think it's not yet there. But honestly speaking, I think it should be. The discussion here would be around, because we are not using uh, the NPUs, or no, not the NPUs. How do you call it? The We are using GPUs. MLX uses mostly GPUs, and we are not using the specialized part of the chip that Apple designed for this.
Got it. And Core ML does use
Yes.
those.
Yes.
Does MLX, is it a not yet thing or is it, not possible? Or does the MLX team not have access to something that doesn't allow them to use these AI focused components on the chips?
I think it's mostly because MLX is most right now focused on GPUs, and GPUs, as you know, especially on the phone, won't be as efficient as the neural engine. So the neural engine is specialized for this. It consumes less energy than if you were running the GPU. So especially for iPhones, I think this might be a concern. Um, but when it comes to
Yeah.
your Mac,
And my
your
question is like, why doesn't MLX use the neural engine? Did the MLX engineers like not have access to it, or is it incompatible ideologically with what MLX is trying to do? Like it
that's
would
a
seem
really
like,
That's a really good question. I think I will ask Henry about it. Like, I tried to think about it, but I didn't go too deep, because for me personally, as a researcher, GPU is what you mostly use, especially if you want to run some fine tuning, some training, and it's just a much direct approach to building this. I think building a strategy where you use the neural engine and the GPU might be a bit more complicated and harder to do than it is for you to use the GPU and the RAM. So the unified RAM architecture between CPU, GPU, and the RAM makes it much easier for you to move around data. But if you want to do that and also put it into the neural engine, I think it might be a bit more complicated to do. But I will definitely ask him and get that answer for you. And I'll post it on Twitter when I get it.
okay. Do you have a sense for how the neural engine is used relative to the GPUs? Like, are there, are you able to do the same things in terms of local inference with the neural engine, or do you have? I'm imagining that you likely have maybe memory bandwidth constraints or other types of constraints that make it like it's for smaller models than the ones that you're starting to deal with nowadays with MLX.
Exactly. So there was a discussion around this on Twitter, and I think there's a guy called Ani ML on on Twitter, and he's one of the main persons focused on Core ML, as well as Anui. I saw the discussion, and the discussion was exactly about this. So the neural engine, you cannot fit as big of a model that compared to the GPU. So you would be very limited in terms of the models you fit and how you fit them. So for MLX, you can just take any Hugging Face Safe Tensors model, download it, and it will run. For the neural engine, you need to make all those optimizations and trace the model a certain way so they will be able to run. And also the size of the memory, or the size of the model, will be constrained because of that.
Does the neural engine exist on the desktop Apple Silicon devices or only on the mobile devices?
No, it exists on all.
Okay.
So you have access to the neural engine. It's just that right now you can't necessarily choose that because we don't have a platform that would give you that performance trade off. So it's mostly GPU. I think it's the most pervasive around all of them. So you can the same architecture can be used for iPad, iPhone, even Apple TV if they do put Apple Silicon there, as well as Mac. So it's just much easier that way, and you can load really large models. You can, for example, load a 20 something billion parameter model quantized down to 4-bit on a M1 with 16 gigabytes of RAM. You wouldn't be able to load that big of a model into the neural engine.
Yeah, most recently, we've seen folks, I've seen a lot of chatter on Twitter about the new OpenAI uh, open source models and folks trying to get these running on, very old and, much smaller, like these 16 gig M1 Max. And apparently they do work. Performance isn't amazing though.
It is possible. I think we could optimize inference further, especially for mixture of experts. I have a counterintuitive argument, which is we have those experts and they are active at different times. You're not loading, you don't need all those experts in memory. If we could find a way to quickly uh, load only the experts needed during the particular inference step that you're doing, we could be able to run it at a more like a faster pace. But that's something that's not yet been done. I know this because last year I ran inference on Mistral, the Mixtral, which is the mixture of experts model from Mistral, across two Apple Silicon devices. I was capped, of course, by the bandwidth of the smaller one, which is the M1, but I could get around 4 tokens per second. And my idea was we could offload the expert layers to a more powerful machine and quickly do this hot swapping between GPU, CPU, between the experts, and you could reach decent speeds. So I got about reading speeds, which is around 4 tokens per second using Thunderbolt 4, yeah, 5. Yeah, Thunderbolt 5. So we could definitely optimize it further. And who knows, potentially in the future, be able to run this in a smaller device by pruning some of the experts away and getting a much more compact model that is just decent for the particular task.
So the pruning that you're talking about is like a real time adaptive pruning. Like you wouldn't be eliminating experts altogether. You would be swapping them in and out on the fly, like trying to anticipate which expert is being invoked for a given inference.
This is a very interesting question because when I was at RC, it was one of the things that I was working on as well, which is I created me and a colleague of mine created something called Fusion. And the idea of Fusion came because I was working on pruning. So when I joined RC, I had released Llama, the world's first Llama 3 with 6 billion parameters by pruning the 8 billion parameter model and then doing continuous pre-training on that model. So I could actually recover more than 75% of the performance of the 8 billion parameter model in the 6 billion. So my idea when I joined was, okay, let's explore and see if we can prune the width of the model, so the neurons of the model or the layers. And within that research, I found something very strange. When I was trying to do pruning of neurons, I found out that if I apply pruning on particular neurons, you could keep the language of the model, so the model could still speak English. And then when you apply it to others, the model will completely collapse. And I was like, okay, this is very interesting. I talked to this colleague of mine, Fernando, and I said, hey, I'm seeing this really weird behavior. Every single time I prune the model, since it's at random, I get different behaviors. I expected a similar, somewhat behavior, but even if you do somewhat closer or less random approaches, the model will still behave completely different. And we theorized that there is a sub network within each model, whether dense or expert, that is responsible for certain behaviors of the model. So, meaning it's responsible for cognitive behavior, meaning be able to do math, or linguistic behavior, which is be able to understand English and output English. And then we ended up making Fusion, which is basically an algorithm that scans your model and is able to find the most important characteristics of the model or the strongest characteristics, and you can actually take those and apply it to a different model, and then the resulting model will have characteristics of both parents without any training. This brings me
This
back.
is based only on, access to the weights. It's
Yes,
not
just to the
based
weight.
on like querying the model.
No, no, there's zero queries. I'll give you a precise example of this. So we tested out something. He fine tuned Phi 3. I think, yeah, I think it's Phi 3.5 or 3 to do function calling. And then we took the function that particular model and merged it with the original model, right? Fused, not necessarily merged, but merging is just
Through
a
this
simpler
fusion
word.
process.
Do the fusion process with the original model. The original model initially could not do parallel function calling, but after fusing with this checkpoint, we could now do how do you call it? Parallel function calling, and the resulting model had better performance than both models combined. Oh, not combined, but better than both models on average. And this is with zero training, just access to the weights.
That doesn't sound surprising if we're talking about the same model. Like you have one, if I'm understanding the scenario, you took Phi 3 and you trained it, and then you took another Phi 3 and you like, that seems like you could just do a diff on the weights and like move over things that change, and then you would get the new behavior and the.
Not necessarily. It's not that simple. So merging already existed for a very long time. You have Slurp, you have all other techniques, but fusion it actually surpasses merging by a mile. Like in terms of performance, it's reliably better overall. And we also did another experiment where we were fine tuning a model, and by fusing intermediate checkpoints until the end, you end up with a much better model at the end in terms of eval performance across the board compared to just taking all models or even doing traditional merging.
Are you saying that you're, um, I guess I'm trying to get at like what, maybe where I'm oversimplifying it, or where I don't have the right mental model of this. Like, what would be more compelling to me is if either like you're able to do this fusion across model families, which just sounds
Yeah,
like really hard and messy.
no, you can.
Okay, okay.
You can.
Or
That's the
like,
beauty.
you've got, a version of a model and you okay, you've post trained both models, and this model is post trained to do X, and this model is post trained to do Y, and you are able to fuse them, and this model can still do X, and now it can do Y. Like these are.
That is exactly what Fusion does.
Okay.
So it's not only about those examples I gave, but it does this reliably. There's a paper from a China university, T something. I don't want to botch the name. There are papers from Cohere now talking about this. So it is a pretty great new technique. So it's capable of doing this, and because of that research that I was doing, it brings back the idea that with especially a mixture of experts, we could do a lot of things to optimize them. We could do early exit. So for, instead of processing the token all the way down, we could find a mechanism or ways to train the model to skip and just go to the end. That would improve performance. Another one would be offloading the experts to the CPU. You don't need all the experts loaded at all times, and there are ways of doing this without having a query to test this out, and there are ways to do it. It just depends on what you want to do and what are your constraints. If you're on mobile, you definitely don't want to be doing this on the fly optimization, you probably will just create a submodel that has those properties that you want to run on mobile. But if you have more resources like on PC, you should be able to just do this on the fly.
Okay. Interesting. Interesting. Um, and so taking a step back and talking a little bit about like the you talked about how you've kind of moved 1,000, models over to MLX. I'd like to understand when you're approaching a new model, like what that process looks like. You mentioned quantization, you mentioned pruning. These are things that we've talked about on the podcast quite a bit. Like, but how are you thinking about the process?
So I actually have a YouTube video on this where I walk people through the entire process. But basically, my process is quite simple. I go to Hugging Face. I go look at the configuration of the model. Usually, most models have a similar architecture, so the model type matters a lot. You should be able to see the model type and know whether it already exists in MLX or not. If it doesn't, I go ahead and look at the
In this case, is something like transformer based or something
not
else, or is it a
necessarily.
higher level?
It's a higher level argument in the configuration of the model that you can use to see whether, usually in MLX right now, all of the models, the name of the file of the file, the Python file or the folder of the Python files is actually the model type. So that when we are
Talking about like safe vectors versus another kind of artifact or something else? Like what are examples of types?
okay, so basically let's take Cohere. So they have command R. Let's say the model type is command R. In MLX-LM, if you go to MLX-LM and then you look at the models folder, you should be able to see command r.py. That file contains all the code necessary to run inference using that model, right? So that's what I mean by model type. Hugging Face uses model type to load the tokenizer, to load, I think model weights as well, and we just do it a more direct approach by calling the model type as the model file. And what I mean by that is like, usually, if it already exists, you just run the model. You just download the model from Hugging Face and run it through the CLI or through your own Python script. Usually, it's just MLX name of the project dot generate, and that should be enough to generate an initial response. Um, if that does not exist, then I go look at the transformers implementation, which they usually have a transformers implementation. I look at the code and I just convert one by one. MLX in is very similar to PyTorch in terms of the API design. Um, it's more inspired by NumPy and JAX, but it overall is pretty close. If you put them side by side, you'll be able to see where the commonalities are. So you just look at the Python class. Let's say it's defining the vision part of the model. You just take that code and look at the MLX syntax, and you should be able to convert it pretty easily. There are a lot of foot guns because MLX does things differently from PyTorch. You have to have experience with that, but it's pretty easy because we already have a lot of examples. So if you see a particular component on, let's say, Command R, and then they release Command A, if you go to Command A and you see that it has a similar class that already exists in MLX, you can just copy that in, and you should be okay. I'm talking in terms of like beginners. Advanced people, I would just say spend time in the MLX documentation, spend time looking at the code that already exists, spend time looking at the PRs of adding support for new models, especially the family of models that you want to add. And then you'll be able to see the pattern and you'll be able to see what you need to do. Um, in very rare cases, you will need to pretty much write something from scratch, and those are the hardest ones. So with MLX Audio, for example, I had to write a lot of layers from scratch that don't exist in MLX right now. Then I send some PRs, and some people help me send some PRs to MLX to add those layers in, but those are very rare cases. It only happened to me because audio, it wasn't really as front and center for MLX initially, but now it's kind of taking up that space, and they are more aware that audio is kind of taking growing, as well as video. So usually I just look at the config file, identify whether it exists or not. Second step, I just implement it if it doesn't exist. And after that, I just make a new release, and the models are on MLX. After that, after the release is done, I usually upload all of the model weights to MLX in particular setups. So the first one is quantized to 3 bits, quantized to 4 bits, quantized to 5 bits, 6, 8, and bfloat 16, which is usually half precision from the original models. Some models are float 32. I just do half of that. We still keep the same quality and speed compared to the original, and people can just choose. So if you have a smaller machine, let's say an M1, M1 Pro, you can go for the 3-bit, 4-bit models, or even 5, depending on your RAM configuration. And then if you have more performance, you have a kind of middle range MacBook to high range, you can go for the 8-bit or 6, 8, and bfloat 16.
Are you just like programmatically producing the various quantized versions of the models and uploading them, or are you doing like testing to determine like where that performance quality sweet spot is? And okay, for this one, 4-bit works, but 2-bit doesn't work. For this one, we can get it down to 2-bit. Like, or is it like you just do it and it's up to the user to determine what works for them and where they want to make that trade off?
Wow, Sam, the questions are really good. So, uh, initially, I used to do this by hand. I would do one by one manually and test them. But nowadays, I have to port an average of like 2 to 3 models a day, sometimes. Um, and that is just, and sometimes even more, depends. Like in the morning could be OpenAI, in the afternoon could be Anthropic, and evening could be Mistral. So I never really know who's releasing. So what I do, I test out the 4-bit and 3-bit. Those are the two that I see the results. And then the rest I don't see the results because I expect the performance to be good. I expect the performance of those ones to be good out of the box. But the 3-bit, some models just are too small or too fragile or sensitive to quantization that 3-bit will not give you any good outputs. So I watch out for those. 4-bit is usually standard. It just works. Might not give you the best performance when it comes to, for example, vision language models, but it works pretty well for text and audio, because even when you think about audio, it's especially the more recent audio models, there are language models. So the tokens they are outputting are, you could imagine them as just normal text tokens. So they are a bit more resilient to quantization. But vision models, they are quite sensitive. So 3 bits, you have to see how big the model is. If the model, let's say, is 1 billion parameter, probably doesn't make sense to make a 3-bit version of that model because it's too small. To You're compressing the
Too
model
much
too much.
compression. Mhm.
Yes. So I usually just test out those two, and then the rest I upload, and I wait for community feedback. Right now on Hugging Face, I have, let me just quote this correctly. On Hugging Face, I have over 10,000 notifications.
These are people that want you to port their model to MLX,
Sorry,
or that
correction, not 10,000, 1,700, sorry, not 10,000, but 1,700. These are people giving me feedback on particular models, asking for port of new models, and usually these also end up on GitHub. Um, and I just have lots of notifications. I think 10,000 is because I also have email, and in overall I was counting this week. I have over 10,000 notifications across all platforms. So, so yeah, I
I'm imagining you building like some LLM based thing to like go through all these notifications and
I
like
talk about that a lot. I actually released a video recently talking about cloud code because my expectation, I had this dream I actually posted. I want a system that could be a great um, intern for me because I want someone to check out the PRs. I want someone to see the GitHub issues across all my projects and just notify me if there's anything. I already have a body of work, so the model could just see whether the new PR has the standard that I want, or just give me an initial breakdown of what is there because it's like too many things to manage. But we're not there yet. It's still a long way to go before we get to an agent that you can reliably say, "Here are the keys to my life. Go wild." Plus, I really, especially with open source, I want people to know that I care, know that I am there. I'm reading every single notification. I just usually keep them as unread because it's easier to go back to some of these notifications. On Hugging Face, I don't check because it's too much. Like there's a lot of things going on. GitHub for sure, it's me. It's always me. I'm there all the time.
you've talked about quantization so far, pruning you mentioned as well. Like, is that uh an extraordinary thing that you do, a regular thing that you do? Like when do you incorporate pruning into the process of porting a model over?
Okay, so I didn't mention this. So with quantization, there are a couple new techniques, especially the ones developed by Anhui and the MLX team. One is called DWQ and AWQ. AWQ, everyone already knows, which is activation aware quantization. Basically, at inference time, you figure out which neurons fire the best, and you quantize the rest. And then DWQ is more of a quantize the model down and then use a higher precision model, either an 8-bit, for example, if you quantize the model to 4-bit, or you use the full precision model and you do this sort of distillation. So basically, you're taking the model, quantizing it, and recovering some of that performance through distillation. I am quite familiar with this. At RC, we worked on Distill Kit. It was one of the things that we were pretty much the best at doing. And we created this toolkit where people can do it as well. That technique is pretty good. Right now, I just don't do it because it requires a lot of compute. I'm waiting on the M3 Ultra that the community got me to be able to do that. So once the M3 Ultra gets here, I'll be doing more of these specialized fine tuning of quantization models or quantized models. Additionally, with pruning, I think it also falls into this bucket. It requires some compute to recover the performance of the original model, which means you have to take some data set and train the model, train the model again a little bit, or have a LoRa to be able to recover that performance. Because what you're doing at the end of the day is cutting the model dry. You're just going in and say, "Hey, you are out, you're out, you're out, you're out." Even if you have some sort of metric that tells you which neurons to prune, which is something that I do. I created already the algorithm to do this. You still need some training. Usually, you would need an A100 cluster of GPUs to do this, and I'm just waiting to get a more powerful machine to be able to test out some of these new techniques that can improve the performance of quantized models. But I'll give a shout out to actually DeepMind. They have been creating a lot of quantized aware models that they train already beforehand uh, towards being optimized to 4-bit or even lower quantizations. So if more companies did that, I think that would actually save me the time and save a lot of people from the community the time.
So thus far, we've primarily been talking about models that other people create and you help port over to MLX. But in the intro, and you've mentioned MLX-Audio, I believe. There's also MLX-Embeddings, MLX-VLM. Like these are models that you've created.
So MLX audio and embeddings and MLX VLM are mostly packages for doing inference, fine tuning of these models, and some sort and other optimizations there as well. Now we are actually working on a model.
Before we get to that model, then, so these are all similar to when you mentioned audio. Like MLX is the foundation, but in order to support audio models, there's a core set of components that are required, and that is MLX Audio. You've like built out this kind of audio adaptation layer, or you tell me what you call it, but that's the way I'm thinking
You
of
can
it.
think of it as a package or Python library, and even Swift. We also have a Swift package that allows you to run inference of all the models that we port. So just like MLX-LM, we when we see a new model in audio, we port it there, and we provide you the way to do inference. And this can sit on top of your applications as your local inference engine. We have servers, so you can instantiate a server that runs on your MacBook and serve it to your network. So you'll be able to generate audio or process audio on the fly in your network, or use the Swift implementation where you can build an application with MLX audio components built within. So you'll be able to generate audio, do audio understanding, and more.
Got it. So the way to think about this is I've got a model that's a file that's a bunch of weights that's structured in a particular way. MLX knows how to take those weights and like do the math that's required to constitute a model. But then you still have this problem of efficiently invoking or using MLX to do an actual inference, and that's what these libraries are, for audio and embeddings and VLM.
Exactly. So it's quite interesting. I ended up creating more libraries that I wanted to. MLX-VLM now is basically an Omni package. So we do inference of more than vision language models. We now do inference of models that support audio as well. So I wish all of this could be like one package, but unfortunately, just for the sake of my sanity, I needed to separate them and be able to think about them individually.
But maybe MLX VLM comes to supersede all these other models and becomes like a single package for MLX inference.
I think this is going that way, especially with the event of what I call media models. So models nowadays not only support text or vision as input, they support audio. That is something we support at the moment. Soon we will support. Also, we support video. We could consider that as well. But soon we will support even more types of modalities, and eventually I see all of that kind of falling into MLX VLM. Then I would have the problem of renaming it to something, either MLXO, because Omni is taken, so I have to think about a new name. But eventually, I think that is the direction the industry is going overall. I'll talk more about that later, but right now, MLX Audio is focused only on audio models. So if you want to do text to speech to text, and speech to speech, you can use MLX Audio. A great example of this, I don't know if you heard of Unmute from Qt. We have a similar pipeline that we released to open source weeks prior to their launch, which basically what our pipeline does, it's called a modular speech to speech pipeline. It allows you to take any language model or vision language model and turn that into a speech to speech conversation. So you can turn that model into a chat GPT with voice, for example. So you'll be able to speak to it and have it speak back to you, and you can use whatever language model or vision language model you are most interested in.
Interesting. And so, like, how is that working? I got the impression that in order to have a, let's say useful experience for speech to speech, like you have to very tightly optimize that loop. Um, and so like being able to to say that you have like an abstracted one that you can just plug in any model, like that sounds hard.
No, it actually works. So the beauty of it is the entire pipeline runs on MLX. So all of the models. So the speech to text model is MLX model. So right now we support Whisper and Parkit, which are the top uh, automatic speech
Parakeet's the
recognition models.
NVIDIA,
Yeah,
recently
the
released
NVIDIA model.
NVIDIA model.
Yeah. And we also support Gemma 3N through MLX-VLM. So Gemma 3N also supports audio, vision, and text as input. So you could also count that as one model there. Then we have the language model component. You can take any language model or vision language model supported by MLX and use it there. So you can use a model quantized to 3-bit, 4-bit, whatever quantization you want, in whatever model we support. And then we have the text to speech part, which is are also on MLX, and it was how MLX-Audio was created. So you can choose Cockerel, which is an 82 million parameter model. It's tiny, tiny, tiny model. You can use all of the existing models we have, including Sesame and etc. And our upcoming model that is going to bridge that gap, because right now all of the existing models don't do streaming of responses. And if you were to do this to stream the audio back, it will be super choppy. We are solving that, and our model is able to do pretty much real time on M3 Max. Full precision. So this is full precision. If you quantize it down, we should be able to do real time or close to real time, even on a M1 Pro and probably potentially M1.
And this is with the new model you're working on?
Yes, it's called Marvis. So it should be out. Yes, my really awesome real time intelligence system. It's
As
a
opposed to
it's
just another.
as opposed to Jarvis. So this is where we are super excited, and I'll share more details about this later today.
Okay. Okay. Um, Later today in our conversation or later today on Twitter?
In our conversation as well as on Twitter. So
Let's do it. Share more details. Tell us about Marvis.
with Marvis, we wanted to solve the problem that we also had with the modular speech pipeline. It's pretty fast, but if you want quality and you want to be able to stream, let's say you have a really large text that was outputted by your language model. With previous models, you'd have to divide characters every 100 probably characters or every 100 words and be able to create audio for those individual parts or paragraphs. And that is not good because the audio will be super choppy. One, second, you'll have interruptions that are unnecessary, so the audio will not feel natural. You'll see, for example, you might have to have a break mid sentence because if you generate any longer than that, it's going to take a long time for the user to hear the feedback. We found out about a particular decoder that is able to do streaming. So we have around 80 milliseconds of response time for the first audio. And I was like, okay, this is great. But there's no model within the category that we are aiming for, which is just a few hundred million parameters or even just a few million parameters. So we set out to build this model, and I'm very happy to announce that we succeeded in that. We have our first model. It is about 250 million parameters, and it can run real time on Apple Silicon. Um, and you'll be able to pretty much hear the voice as it comes with no breaks or even like lag detected.
Talk to me about like what the model is. Is it a port of some other model? Is it a post-trained version of an open model? Is it a ground up model?
So we built this model from scratch. We are training it from scratch. It is based on an existing model which is called Sesame. We kind of were inspired by the data they shared, which is not a lot. We only have the inference code and some blog articles to go from, but we managed to reverse engineer most of it to be able to have a great model. And we trained it from scratch using a few uh, NVIDIA cards. Initially, it was a cluster, so I burned $700 initially training the first version. It turns out we needed to optimize a few things. We optimized those further, and now we are training using a single GPU card. And we just finished training of the first version. Now we are training a even smaller version of the previous one, so that people with even less capable machines will be able to run Marvis close to real time. So it's basically the architecture is basically a language model. It's a language model that gets your text in and outputs audio tokens, and those audio tokens are decoded into audio at the high level. But we will have the data, we will have the article, the code, everything will be open sourced.
What are some of the things that you're seeing folks do with kind of these speech to speech models, primarily like audio assistant types of experiences, or have you seen anything that really blew your mind?
To answer that question, I need to go back a little bit in time. Late last year, I was making a demo for Data Science Summit. I think the shirt I'm wearing right now. I've been speaking there for pretty much the past 3 years. And I was thinking about an audio solution because I had one problem. I created a computer use system using VLM. So I had a MLX-VLM model, analyze my screen, and be able to click stuff and achieve a certain task based on my input. But every single time I had to start a task, I had to walk to the computer. And that became annoying. And I said, why do I have a computer agent, but I have to sit in front of the computer and have to watch it do everything I told it to do? I don't want that. If it's an agent, it's supposed to be kind of in the background doing this, and I should be able to command it in any way, shape, or form. Um, and on top of that, I think the major reason why I created MLX Audio is because my father is actually blind, and he became blind in the past 5 years, and he loves to read. And I told him, "Hey, I will help you read." I think in 2020, I promised him that I'll help him read and navigate the world again. It's part of the reason why I created MLX VLM to help him see. So he has an iPhone. He'll be able to like navigate the world and be able to detect what's in front of him. I actually made some glasses for him, but those are just not Ray-Ban quality. They would be super bulky for him. On a hackathon, I made some glasses that would help him see the world, but it didn't work
I
out.
just saw there's a group that's doing like an open platform glasses. Have you seen that?
Well, if I get my hands on Yeah, if I get my hands on those, my dad will be able to see the world again. So I promised him I would help him see the world, and ever since I've just been focused on vision and natural language. And now with audio, the task was he loves to read books, but he can't really read physical books anymore. And not every book is on Audible. So I told him, okay, I'm going to generate the audio of the books that you want. So he would give me some books that he wants. I would generate the audio and send it to him. He could listen to those books using MLX audio. And that is like part of the reason. But then going back to the computer use case, I thought, well, what if I could just sit on the sofa the way I'm seated right now, and I could just say, "Hey, Marvis, go ahead and order me this, or find me this, or send an email to Sam saying, hey, this was amazing." That should trigger the agent. The agent should go on and do the task and just give me feedback as it's going. Now I open Chrome. Oh, now I'm actually writing the email. I wrote this to Sam. What do you think? Like, I want that level of interactivity. So I set up to build MLX Audio to solve that problem. And I made a demo, I think, on the first month that I released MLX Audio, doing exactly that. So we now have computer agents that run locally that can be able to speak, which is great. So so with Marvis, this is going to go to the next level, which is actual real time voice agents that can have a full blown natural conversation with you, and it should be close to a conversation you would have with someone that's next to you. And it can also clone voices, so you can use the voice of a loved one, even if you want to. So that could be really cool. For my dad, he hasn't seen me in close to 10 years, so I could make his voice agent sound exactly like me, and I already have that running locally on my machine.
Oh wow, wow. Um, Very cool. I know you did a video recently on Claude Code. I think you mentioned it in our conversation. Also, that would be a great use of a speech to speech agent, so you can like code your way through a Claude Code project as opposed to like using Whisper Flow or something like that to paste into the thing.
Absolutely. It could be even built in Cloud Code. I just don't have the bandwidth. Like I have so many ideas, but I just don't have the bandwidth to do. Like if I were to give into my cravings to create, I would create a million things. That is one use case right there that you can build in. Cloud Code could be able to speak all the thoughts and everything. Because I don't know if about you, but personally, when I am coding with a model, I'm actually more interested in its logic than the answer. I find myself looking at the thought process, opening that tag like thought for 3 minutes, click, let me see what it thought. Ah, this is wrong, this thought is wrong. Then I can already deduce whether the answer is correct or not. So if it could just speak through, now I'm thinking about this, or just, I don't know, find a way to find the most interesting things or summarize the thought process and just speak out. Think that would make collaboration much, much easier.
Well, especially if you can like reduce the latency of like being able to like just have very casually interrupt it and say, well, I don't know about that. Maybe think about it like this and then have it, continue. Like you can do all that with the keyboard, but it's not fluid. Like you're working with the intern that's sitting next to you or you're pair programming with this machine.
You should try our modular speech to speech pipeline. It does exactly that. Like one of the things I wanted is the ability to interrupt it. So I could interrupt it at any time and just say whatever I wanted to do and it will do. Now the question is, I want to be able to empower developers and create the best SDK so that people can just integrate voice into their products and pretty much all of their local solutions, be it open source or enterprise if they want to. And this is what I'm working on, and Marvis is a step towards that.
So is that the next big thing in your world, Marvis, or do you have like big plans beyond that about how it gets like integrated into other things?
I have big plans about how it integrates with everything else, but I am I'm the type of person that is focused on what I can offer and then going step by step. I already mapped, like I have probably the next 3 to 5 years of Marvis in my mind, but I think the most important thing right now is getting it out of the door, getting people to use it, and then we'll be able to do really, really cool things. I don't want to say too much, but we already have really great examples of what Marvis could do. You should be able to, for example, manipulate Marvis to have an actual agent that speaks the way you want it to. Whether you want a Jarvis more relaxed way, or you wanted a more active way, or I could just take all of your audio and say, hey, sound like Sam in terms of cadence, prosody, everything. Just have an agent that sounds exactly like you. I think that is important for me in particular. I think I would love that. I haven't seen my family in a long time, and I think having agents with some of my loved ones' voices would be pretty cool. Or them having me, which would be nice. Then I would annoy them everywhere.
That's funny. Awesome. So we will keep our eyes peeled for Marvis updates and um, get a link from you as to where we can go to look for that. Of course, it'll be on X as well. Um, Very cool. And tell me what else, like, beyond the things that you're working on personally, like, what are you most excited about in the world of AI?
Think the most interesting thing right now is the direction that we are taking. Initially, it was all AGI, AGI, AGI. But now people are realizing that, yes, that is great. It would be a great world, but I want a system that is capable enough or competent enough to have an actual intellectual discussion with me and tell me when I'm wrong w- in a very reliable way. I can trust it. Like, I want a system that I can trust. And I feel like we are moving towards systems that we somewhat can trust.
There's so much backlash to you're absolutely right. This came up in the interview I just did. People are realizing that actually we want something that's going to challenge us and like help, work with us to like produce better things or, think better about the thing that we're asking about.
Exactly. I have a tweet where I say, I said 22 hours ago, I'm waiting for the day it will say you are wrong. Here's why. Delivers facts with sources.
Yeah.
I want
You're
that. Like,
absolutely wrong.
I think I want that. I don't want a system that is just like, ah, you're right, or oh, it's my bad. My bad. What? You are actually right majority of the time. You just have this tiny bug here, and I want you to just fix that one thing. Um, so that is one direction that I'm loving to see companies take on. So they are trying to build new architectures and new training strategies to be able to address that. Second thing is media models. I think of over time, the same way last year when I created MLX-VLM, there was literally very few vision language models. But nowadays, vision language models and including audio models can do function calling. So you can do function calling with your voice, which enables experiences like Marvis. You'll be able to do way more with new types of media. So I'm seeing a lot of interest in audio space. I'm seeing a lot of interest in the video and lip syncing space, as well as new like generation of images. I think going towards a world where newer models can do all of those modalities in one, and and it can do it in a very reliable way and efficient, in the sense that you could get a 1 billion parameter model or 100 million parameter model that could do a few modalities, and you can embed these directly into your products and make your life simpler. To kind of illustrate this, before Gemma 3N, the modular speech-to-speech pipeline, you needed ASR and you needed a language model. Now, with Gemma 3N, you could replace the first component and the second component into one. And actually, third component, which is multimodality with vision. So you now have one model that does audio understanding, does text and image. Now imagine if you could also do other types of processing all in one, or even output audio as well. So now you can simplify your pipeline, and your model your entire system can just run much faster, because you're not loading all of these individual components and try to mesh them together. So I see media models becoming something pretty great. And I intend to pioneer that, at least when it comes to MLX. I really want to have people do this in the best way. Uh, to add to this, I actually have a challenge with someone. Julian challenged me in Germany last month to create a package that's able to generate images and video in under 20 seconds with a few gigabytes. And I'm taking on that challenge. So look up to that as well.
And the goal there is something along the lines of Sora or Veo or
Yeah.
uh okay,
But it runs completely offline
completely
and
locally
on, yes, and locally. So I
on
really
Apple
want to
Silicon.
do that. Yeah. I want to do that. I think the world is going to benefit a lot from it.
Uh-huh.
And who knows, perhaps the whole equipment here for the audio, because it's for the studio, might be replaced. In some videos, I might just take a copy of me and make and make a video, a generated video, and say, hey guys, at least I thought it through, I made the script, and you guys can watch something pretty new.
That's awesome. Awesome.
Yeah.
Well, Prince, it was great chatting with you. Thanks so much for
Thank you very much
jumping
for
on
having me.
and talking a little bit about what you've been up to and how the MLX ecosystem is evolving.
Yeah, absolutely. Thank you very much for having me.
Thank you.